Can PAT testing be carried out by anybody? Or do you need to be an electrician? In this video, we're diving into what competency actually means under the Electricity at Works Regulations 1989, and who can carry out PAT testing and the roles that the Code of Practice actually expects. And then we're going deep into equipment classifications. Class 1, Class 2, Class 2 FE and Class 3, because without understanding these classifications, you can't carry out testing correctly. And once you see how these classifications affect your testing, you'll never look at a toaster or a laptop charger the same again. Competence sits at the very heart of PAT testing, and Regulation 16 of the Electricity at Works Regulations 1989 makes it very clear. It states that no one should carry out work that requires technical knowledge or experience unless they are competent to do so, or they are properly supervised. That is the legal position. So that doesn't mean you need to be an electrician, it just means you need to have the right knowledge and training. Competence in PAT testing is a lot more than knowing how to operate a tester, and the Code of Practice sets out what that competence looks like. A test operative needs to be able to identify the equipment classifications, because it's those classifications that determine the test procedure. Misidentification of classifications can lead to incorrect testing procedures, missed faults, and potential damage to equipment. We must also understand the tester that we are using, not just the button presses, but how the instrument works, its limitations, and when a particular test voltage or method may be unsuitable for the equipment being tested. Repeatable results depend on this knowledge, and so does not damage an equipment during the testing procedure. A competent operative must also be able to complete records accurately and sign them off. That signature confirms their judgment that the equipment is safe for continued use based on the inspection and tests carried out. This is why competence can't be superficial. So the HSE offers guidance and describes two levels of operatives. A level 1 operative uses simple pass or fail instruments and does not interpret readings. This is suitable for low risk equipment where there is no disassembly. A level 2 operative uses instruments that provide numerical values and must interpret those readings. This demands technical understanding and experience. Courses like City and Guilds 2377, EAL's in-service inspection and testing of electrical equipment, and LCL's version of the qualifications are a common way of building this knowledge, especially for inspectors and test operatives. But a qualification on its own does not prove competence. Technical understanding, practical experience, and awareness of hazards all matter. Real competence is built through both training and experience. Where equipment is permanently connected, competence must also extend to safe isolation. Anyone disconnecting or reconnecting equipment must be trained and experienced in the safe isolation procedures. This is critical because safe isolation carried out incorrectly raises a huge risk to the operative. Competence means that the operative can make an informed judgment about the safety of the piece of equipment that's going to be tested. That is competence required by law and the competence expected by the Code of Practice. In lots of places, several people may share responsibility for electrical safety. Almost everyone has a part to play, but not everyone carries the same level of responsibility and not everyone needs the same level of competence. The first role is the user, the person about to use the piece of equipment. They do not need electrical skills, but they must know what to look for. A damaged plug, a split flex, burn marks, loose casings, anything that does not look right. If they see a defect, they must not use the equipment and they must report it. User checks are simple, but they are a critical frontline defense. Many faults are obvious to the naked eye and they can be captured early before any formal inspection is required. The next role is the inspector. This is often the same person who carries out the testing, but the code treats the formal visual inspection as its own discipline. The inspector must be competent to open plugs or fuse spurs where appropriate, check the wiring, confirm the correct fuse is fitted, and decide if the equipment is safe to proceed to testing. They must record the inspection and sign the report. If the equipment fails at this stage, it is removed from service. Then we have the test operative. This is the person who performs the combined inspection and test described in the code. They must carry out electrical tests, interpret the results correctly, and decide whether the equipment is safe for continued use. Training and experience is essential. The test operative must also complete the records accurately and sign them off, as their signature confirms the final judgment. There is also the person who repairs the faulty equipment. They must be competent to work safely on the type of equipment being repaired, understand the hazards associated with reassembly, and make sure the equipment is safe before it goes back into service. Above all of these roles, sits the duty holder. This is usually a manager or supervisor, but the title is not important. What matters is control. If someone controls the equipment or is responsible for the environment in which it is used, they carry the legal responsibility to ensure it's safe. The duty holder must understand the relevant legislation, assess the risk, and put a maintenance regime in place. That includes inspection intervals, record keeping, repairs, replacement, and training. They must also be able to understand the results taken during testing and act on them as necessary. The duty holder can delegate tasks, but they can't delegate responsibility. If they appoint someone to carry out inspection and testing, they must ensure that that person is competent. They must also recognise that not all equipment meets the same standards. Equipment of unknown origin, custom-made equipment, or equipment purchased from outside the EU may not meet recognised safety expectations, and the duty holder must factor that into their risk assessments. So all of these roles work together. The user carries out basic checks, the inspector assesses the equipment more thoroughly, the test operative confirms the safety of the protective measures, and the duty holder manages the entire process. And Regulation 16 of the Electricity at Work Act sits over all of this, requiring some degree of competence at every level where electrical knowledge is needed. So that completes the structure of who does what. So now we can move on to the next question. What are these equipment classifications and why do they matter? But before we get to that, don't forget that this video is one in a series of videos I've made on PAT testing, and you can find the link in the description. And if you've got a question that you want me to answer, then you can send it direct to me at willittrip@efix.co.uk. Okay, so now let's get into classifications, because if we can't understand how the equipment protects the user, then we can't test it correctly. Every item of electrical equipment has one purpose when it comes to user safety: prevent electric shock. To do that, it relies on two layers of protection. The first is basic protection. This prevents accidental contact with live parts during normal use. The most familiar example is insulation around conductors, but inside equipment this could also be insulating barriers. The second is fault protection. This steps in if the basic protection fails. Fault protection might involve connecting metalwork to earth, enclosing live parts inside an insulating case, electrical separation from earth, or supplying the equipment from an extra low voltage source. Some electrical equipment uses a single layer of reinforced insulation that offers both fault and basic protection. The type of protection built into the electrical equipment determines its classification, and that classification tells us exactly what test we should carry out. Okay, so with that foundation, let's start with the most common classification category, Class 1. Class 1 equipment uses exposed metalwork as part of the safety system, and that metalwork must be connected to earth. This is the same protective measure used throughout electrical installations, known as automatic disconnection of supply, or put simply, will blow the fuse or trip if something goes wrong electrically. If the basic insulation fails and a live conductor touches the metal casing, a fault current flows down that protective conductor. That current must be high enough to operate the fuse, circuit breaker, or RCD quickly. Once it trips, the fault is cleared and the danger is removed. So for this to work, the earth connection needs to be intact. The earth pin, the protective conductor in the flexible cable, and the internal earth connections must all be sound. Common Class 1 equipment includes refrigerators, washing machines, kettles, toasters, and electric radiators. Some appliances include markings like the earth symbol or the letters PE, but many do not. The absence of a mark doesn't mean it's not Class 1. We identify the protective measures, not the badge. Class 2 equipment protects the user through insulation alone. There is no earth connection because fault protection is provided entirely by either double insulation or a single layer of reinforced insulation. Televisions, projectors, hairdryers, and chargers are typical examples. Metal parts such as screws are isolated from live conductors by internal insulating barriers. But not all Class 2 equipment looks like plastic. Metal case media players, metal desk lamps, many power tools, luminaires, and some convector heaters may use double or reinforced insulation internally even when metalwork is exposed externally. Class 2 equipment is identified by the double square symbol. The inner square represents basic insulation and the outer square represents supplementary insulation. Class 2 is all about the insulation doing the work. No earth, no reliance on the installation. Class 2 FE can cause some confusion because at first glance it does look like a Class 1 piece of equipment. It does have an earth connection, but that earth is not used as a protective measure. It's used as a functional earth. The most common examples are switched mode power supplies used in IT equipment. These operate at high frequencies and need filters to prevent interference. Those filters create small currents that need a return path, and the protective conductor provides that path. These leakage currents are normal and expected. Even though the equipment has an earth, shock protection still comes from double or reinforced insulation. The earth supports the filter, not the user. Class 3 is defined by electrical separation and not voltage. The equipment is supplied from a source isolated from earth and all other live circuits. There is no intentional earth referenced on the secondary side. Many people assume Class 3 always means extra low voltage. It often does, but not always. You can have Class 3 equipment running at 230 volts through an isolating transformer. An isolating transformer has a separate primary and secondary winding with reinforced insulation between the windings. If you touched a live part on the secondary side of the transformer, you wouldn't receive a shock.
Phew.
Even if you were standing on the greater mass of earth, because no current can flow. There is no return path, and that is the protective principle. So the most common Class 3 arrangements are SELV and PELV. SELV, separated extra low voltage, uses extra low voltage supplied from a source that is electrically separated from earth. This is the safest configuration because even simultaneous contact with earth cannot cause a dangerous shock. PELV, protected extra low voltage, also uses extra low voltage, but the system may be earthed at one point for functional reasons. Both SELV and PELV appear in LED drivers, control circuits, chargers, and toys. Energy Source Class 1 or ES1 is similar to SELV in the fact that it uses an extra low voltage to reduce the shock risk. ES1 sources cannot exceed 30 volts AC or 60 volts DC. In many installations they are below 12 volts AC. The key difference is SELV is electrically separated from earth and ES1 does not need to be. ES1 limits the shock risk through low voltage. We do have two more classifications featured in the Code of Practice, but they have no place in modern UK practice. Class 0 relies on basic insulation only. No supplementary insulation, no earth connection. If the insulation fails, the user is relying on the environment for protection, and this is unacceptable in the UK.
Unacceptable.
Class 01 came from a withdrawn standard. It describes equipment built as Class 1 but fitted with 2-core cable and a plug that cannot be inserted into an earthed socket. Neither Class 0 or Class 01 should appear in normal UK workplaces. But if you have ever come across them, please let me know in the comments. I'd love to hear your stories. So there we have it, the complete set of equipment classifications and confirmation that you don't need to be an electrician to carry out the in-service inspection and testing of electrical equipment, or PAT testing. You just need competence and experience. In the next video, we're going to be moving from theory to practice. We will break down the full testing and inspecting procedure step by step, show what each test actually proves and how to correctly apply it to each classification. So hit the video on screen now.